Here are solutions to quiz number 2 for ECE 320. The first problem is short answer, asking what are holes, what are electrons? Well, holes are covalent bonds which are missing an electron. The hole acts as a positive charge carrier. An electron is a negatively charged particle that forms covalent bonds. Free electrons carry charge. And actually, we don't really know what electrons are. We think they're fundamental particles, meaning quarks, but again, no one's really quite sure. Part B asks, why does the resistance of semiconductors go up or go down as temperature goes up, whereas metals go up? For example, if you have a piece of metal, and I've got the temperature versus resistance, for metals, the resistance goes up slightly with temperature. For semiconductors, on the other hand, come on, puppy dog. Semiconductors, the resistance drops pretty dramatically. How come? Well, with semiconductors, as temperature goes up, you get more and more thermal holes and electrons. More charge carriers means less resistance. On to problem 2. On problem 2, I have a resistor with the following dimensions, and the dimensions actually aren't quite right, but just go with it. So here's the dimensions. What doping do I need for a resistance of 1314 ohms? And that depends upon your birth date. Well, the equations I need are the resistance is the resistivity times length over area. The conductivity is 1 over resistivity. That's the number of charge carriers times charge per carrier times mobility. So 1314 ohms is the resistivity times, using these numbers up here, there's the length. The area is width times height. Gives a resistivity of 4.2 ohm centimeters. That's equal to, 1 over that is equal to the number of charge carriers times the charge per carrier times mobility. I get a doping of 2.9 times 10 to the 15th atoms per cubic centimeter. Problem 3. If I have this circuit and I measure 6.2 volts and R depends upon your birth date, for me I assumed 1314 ohms. Find the resistance RT, find the temperature. Well, from voltage division, I know that V1 is voltage division times V0. Doing a little bit of algebra, I get RT is the voltage over 10 minus voltage times resistance. So this has got to be 2143 ohms. Well, I know from the thermistor equation, that's the resistance solved for temperature. So again, the procedure is you divide by 1500, take the log of both sides, bring this left, invert, solve for T. I get T is 17.2 degrees Celsius. Problem 4, a load line. Given this circuit, draw the load line and find the voltage and the current. So for the load line, on the x-axis, let's bring it down a little bit. On the x-axis, if there's no current flow, I have I times R is 0. I see the full 5.5 volts. If I short this, I have 5 volts divided by R, 5 over 1314 ohms is 4.186 milliamps. That's right here. Draw a straight line between them where the intersect is your solution. And that's roughly 2 volts, 2.6 milliamps. Problem 5. Write the equations you don't have to solve. So again, for a diode, it always goes anode to cathode. This is V sub D. That's the voltage that goes up here. So this voltage, anode to cathode, is V sub D. And this voltage, anode to cathode, that's voltage across the diode. Substitute. For diode 1, the voltage across the diode is V0 minus V1. For diode 2 is V1 minus V2. Diode 3, V3 minus V2. So those would be the first 3 equations. Just goes anode to cathode. Next, write the node equations. V0 equals 10. At node 1, the current left, current down, current right add to 0. Current left is minus ID1 plus ID2 plus V1 minus V4 over 100. Gives you this equation. At diode 2, current left, current down, current right equals 0, minus ID2 minus ID3 plus B2 minus B4 over 200 equals 0. At diode 3, these add to 0, plus ID3 plus B3 minus B4 over 300 equals 0. And node 4, these 4 have to add to 0, which is this equation. So those are the equations that have to be solved to find the voltages V1, V2, V3, V4. Problem 6. Write the equations for this circuit. Again, write the diode equations first. Here's the voltage across the first diode. That's V1 minus V2. Voltage across the second diode, V1 minus V3. Voltage across the third diode, V4 minus V1. So those would be your 3 diode equations. Now at node 1, the currents add to 0. So the current left is V1 minus V0 over 100, plus ID1, plus ID2, minus ID3. Gives you this equation. At node 2, current up and current down add to 0. Current up is minus ID1, plus V2 over 200, V3, minus ID2, plus V3 over 300, plus ID3, plus V4 over 400. Gives you the equations that need to be solved to solve for this circuit. So that is quiz number 2 for ECE 320.